Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, up to now we have studied two models for BJT AC analysis or amplifier modeling. The first model that I told you was the T model, or I called it as the RE model, and the second model was the hybrid equivalent model, or you can say H parameters of a two-port network. Also, I told you earlier about one of the models called as Ebers-Moll model, that is the most general and the non-linear model, which is not generally used for amplifier modeling, because in amplifier we are biasing the transistor in active region. So the other three models, that is RE model, H parameter model, and the model that we'll be studying today, are only applicable for active region. Remember this thing. The three most prominent models that are being used for problem solving are only valid in active region, whereas the Ebers-Moll model is valid for all the four operating regions of BJT. But what is the major concern with the Ebers-Moll model? That the model is non-linear and it is a large signal model. So today we'll be discussing about the third model that is generally used for BJT AC analysis, called as hybrid pi model. Okay. Now what is the best feature of this model is, this model is mainly used for AC analysis of BJT at high frequency. Okay. So when we will be studying frequency response, then I will be only using this model. So remember, this is mostly used at high frequency. In high frequency, we will show the resistance as well as the capacitance. We will show both the elements, resistance as well as the capacitance. But this resistance, the resistance in the model resistance of hybrid pi, can be related to either RE model or you can say H model. But capacitances you cannot relate, because till now we haven't used any capacitance. So the resistance part of this model can be correlated with the two models that we have studied so far. But capacitances I will introduce later on when we will be talking about the frequency response. Right now I won't talk about capacitance. So if you see the diagram on your screen, you can see that there are various elements that I have placed in this circuit. I'll discuss about each parameter one by one. First thing, this model I have drawn for the case of common ammeter, and that is why the input voltage I am showing as VBE and output voltage as VC. So first I'll talk about the resistance RB. RB is called as ohmic base spreading resistance. Now what does it mean? It means when we are creating a BJT, okay, when we are creating a BJT, we know that the base area is smallest, and we have to form a ohmic contact. Okay, this is your ohmic contact. Now since base area is smallest, the resistance of this ohmic contact is highest. This is simply rho L by A, where A is area of contact. Since area of base is less than area of ammeter, not less than equal to, actually much less than, which is less than area of collector, which means this RB is much greater than RE, which is greater than RC. So this is very high as compared to these two. So these two are ignored. When we talk about contact resistance, we'll only include this base resistance, okay? Because these two resistances RE and RC are very small, so we are ignoring them. We are only considering the base spreading resistance because the base area is smallest and its resistance is highest. The next parameter, if you see, is the resistance R pi. So R pi is base emitter junction resistance when the junction is forward biased. Okay, it is base emitter junction resistance, that is your R pi. It is actually equal to HFE by GM. Now what is this GM? GM is the transconductance that I taught when we were discussing the common emitter configuration. There I told the transconductance is defined as ratio of output current to the input voltage, which we found as ICQ by VT. VT is the thermal voltage. Okay. So that is your transconductance. HFE is the common emitter current gain, which is also equal to beta. So it is beta by GM. So that is your transconductance. Then the next resistance that you can see is R mu. Okay. This R mu connects the collector and the base terminal. Is it fine? So if you see, R mu is resistance between output and input terminal. Since it connects the output back to the input, so it works as a feedback resistance. Now this feedback appears due to early effect, which means again, if we ignore early effect, R mu will be ignored. This resistance is very high, of the order of mega ohm. So if someone tells you in the question that ignore early effect, you will open circuit the resistance R mu. Similarly, R naught. R naught is output resistance, which is again due to early effect. Okay. So R naught and R mu indicate early effect. Just like in hybrid model we were showing HR and HO. So HR and HO represented early effect. Similarly here R mu and R naught represent early effect. RB is the resistance of the base contact, which is high, and R pi is the resistance of emitter base junction. Emitter base junction behaves as a diode, so it is the resistance of emitter base junction in forward bias condition, and GM is the transconductance. Okay, this is the model that is most commonly employed for analysis of BJT. So all these parameters are important, but most of the times this R mu will be ignored on account of early effect, okay, which will simplify the model. So when we talk about simplified hybrid pi model, you can see that R mu has been removed. The input current is I pi and the IB, and the output current is IC. This basically is actually a dependent current source, that is GM V pi. So you can call it as voltage controlled current source. Is it fine? Because it is a current source and it depends on the voltage. Which voltage? V pi. And V pi is nothing but the voltage across the R pi resistance. Is it fine? Like when we were talking about the T model or the RE model, there the current source was beta IB. So it was current controlled current source because the current source was depending upon the current IB. Here the current source depends on the resistance voltage V pi. So it is voltage controlled current source. Is it fine? So now if you see the simplified hybrid pi model, we have R pi, GM V pi and R naught. And if R naught is high, you can also remove this R naught, and what we will be left with is a resistance and a current source, which is very similar to the RE model. What is the major difference? The major difference from RE model is the current source. There was beta IB, but here the current source is GM V pi. There it was current controlled current source, here it is voltage controlled current source. Is it fine? So now here if you see this, the total collector current, how you can write? It is VCE by R naught plus GM V pi, and in this circuit V pi is actually equal to VB. So we will take a look at how to use this model, and I will show you how you can analyze different amplifiers. So first let us see common emitter configuration. The circuit given here is directly the AC model of common emitter amplifier. So it is understood that we have done DC analysis. So the step 1 for this model, like in hybrid equivalent model, what I told you, that hybrid parameters will be directly given, you never have to do DC analysis. But in this model and the RE model, you have to perform DC analysis. Okay, in both these models you will perform DC analysis. Then you will find out the collector current ICQ. So here you will find GM is ICQ by VT and R pi is beta by GM. These two parameters we need, and also you can find out R naught, which is VA by ICQ. So these parameters are derived from the DC analysis, and then they will be used for AC analysis. So now suppose I form the circuit, I will draw like this: VS, then RS, then we have reached the base terminal. If you have reached the base terminal, you will show the resistance R pi. So I am ignoring the resistance RB here, so I am directly showing R pi. This is your emitter terminal, and the voltage across this R pi is V pi. Now this emitter terminal will be grounded because this emitter is connected to ground. Then between collector and emitter, we have a current source GM V pi. Okay, then you can show it is in parallel with a resistance R naught, which you can ignore if early effect is ignored. Then you can see between collector and ground we have a resistance RC, and this terminal is V0. So that is your AC model of the BJT. Now we will derive one by one each parameter. So first I want to derive voltage gain. The voltage gain AV, not the overall voltage gain, will be V0 by V pi. Okay. Now how you can calculate this V0? This R0 and RC will be in parallel, and this current will be flowing like this. So V0 will have opposite polarity than what is indicated. Plus minus are like this, but we are getting opposite polarity. So V0 will be minus GM V pi is the current, and what is the resistance total? R0 parallel RC by V pi. So this voltage gain is nothing but minus GM R0 parallel RC. That is the voltage gain. If R0 is high, then this is minus GM RC. Okay, because in case of very high resistance, R0 parallel RC will be approximately equal to RC. Then next thing that I can ask is the output resistance. I have told you time and time again that when you find out output resistance, you have to ignore the load resistance. Since there was no RL shown in the circuit, this R0 will be nothing but R0 parallel RC, which is approximately RC. Then next is the input resistance. Again in input resistance, which resistance you have to ignore? You have to ignore RS. So what is the resistance looking from this terminal? It is R pi. Ri is R pi. Next, last we will derive overall voltage gain. This overall voltage gain is computed from voltage gain by a factor of voltage division, which is Ri by Rs plus Ri. So AV is minus GM RC, Ri is R pi over Rs plus R pi. So that will be your overall voltage gain. Okay. So it is a model which is very similar to your RE model. So you have to use the same sort of analysis when you are solving. Now let us see what happens if ammeter is not directly grounded and we have a resistance RE. I told you what is the purpose of this RE. This RE stabilizes your Q point of BJT. Okay. So again what I'll do is I'll draw the AC model of BJT. So this is Vs, this is Rs. Then we have reached the base terminal. We have reached here. Once we have reached the base terminal, what I'll do is I'll draw a resistance R pi whose voltage will be V pi, and this resistance will be between base and ammeter. Now see this, ammeter is connected to ground by means of a resistance capital RE. Then I will reach the collector. Between collector and ammeter, I will keep a current source GM V pi. Then we can have R0, but if R0 is high, it will be open circuited. Between collector and ground, we have RC. Only open circuit R0 if it is very high. Otherwise, don't open circuit it. This is V0. Okay. So this is the AC model. Now what you have to do is you again have to find out each and every parameter. Okay. So first I will again start from the concept of voltage gain. Okay. So when I am talking about voltage gain, I will write V0 by V pi. Now how to calculate V0? This current is going like this, plus minus, but V0 polarity is opposite. So V0 is minus GM V pi RC. So the voltage here will not be V pi, it will be actually Vin. What is Vin? Vin is the voltage of input terminal or base terminal with respect to ground. Earlier what was happening is, if you see this circuit, ammeter was directly ground. So the voltage of base terminal with respect to ground is equal to V pi. But now since ammeter is not directly connected to ground, Vin is not V pi. Vin is basically the sum of V pi and the voltage across RE. Now how to calculate this voltage? This current in R pi is V pi over R pi. These two currents will get added here. Gm plus 1 by R pi into V pi. So if you want to find out Vn, Gm plus 1 by R pi V pi plus V pi. Okay, that is I am adding these two voltages V pi and the voltage here. So V pi 1 plus Gm plus 1 by R pi. Okay, sorry, into Re. Because that is the current Gm into 1 by R pi. So for voltage you have to multiply it by Re. So V pi 1 plus Gm Re plus Reo by R pi. Now if you take the ratio, V pi will get cancelled. So minus Gm Rc by 1 plus Gm Re plus Re by R pi. It is less than minus Gm Rc. Okay, don't consider this negative sign. I am just talking about the magnitude. So what we can say is, by introduction of this Re, the voltage gain has reduced. Okay. Next we will talk about the input resistance Ri. Okay, I am talking about input resistance Ri. So input resistance Ri is nothing but Vi over Ii. This Vi is V pi 1 plus Gm Re plus Re by R pi. Now this input current. See this input current. This is the input current. How much is it? It is V pi by R pi, and V I have written from here. So input current is V pi over R pi. So it will be 1 plus Gm Re R pi plus Re. So that will be the input resistance. Okay. Next we will consider the concept of output resistance. Now from the circuit you can directly see that this output resistance is nothing but Rc. Last parameter, overall voltage gain. So what I have told you about overall voltage gain? That in overall voltage gain we consider voltage division along with the voltage gain. So the factor of voltage division is Ri by Ri plus Rs, where Ri we have derived here. Okay, you can simplify this factor, not an issue, but remember it is nothing but voltage division into the voltage gain. Okay, so remember due to Re, input resistance increases, it has increased, and also what happens? Sorry, this will also be R pi, and also what happens? The voltage gain decreases. So these two things will always happen when you are introducing the ammeter resistance Re. Is it fine? Next, let us compare the three models that we have studied so far for BJT analysis. So this was the hybrid equivalent model. This is your hybrid pi model, and this one is your Re model. If you see, more or less all are same. So first let us consider this HIE. HIE here becomes R pi, here it becomes beta Re. So I will write HIE equal to R pi. R pi was how much? Beta by Gm. It is actually equal to 1 plus beta Re, which is approximately beta Re. Okay. So these three terms are same: HIE, R pi and beta Re. Then see this current source, HFE IB, beta IB and GM VB. This is current controlled current source. This is current controlled current source, but this is voltage controlled current source. So here HFE is actually equal to beta, whereas GM is ICQ by VT. Okay. Then this HOE, HOE represents actually the conductance, it is not resistance, but R0 is resistance. So HOE is nothing but 1 by RO. So all these three models are related to each other. So what you have to remember, when you calculate transconductance, it is ICQ by VT. When you calculate R pi, it is beta by GM, which is also equal to beta RE, which is also equal to HI. And we know HFE equal to beta and HOE is 1 by R0. So that is the main relation between all the parameters that we have used in the three models of common emitter amplifier. So let me summarize what we have covered in this lecture. I have shown you the general diagram of hybrid pi model, and I have told you that this model is mostly useful at high frequencies. So this is the general diagram: base terminal, emitter terminal, then a dependent current source GM pi in parallel with output resistance R0. Then this is the collector terminal. Okay, so the only difference is we are using a voltage controlled current source, whereas earlier we were using current controlled current source. Okay, that is the major difference. Earlier we were using this source as beta IB, now GM pi. Is it fine? So remember this model, you can use any of the model depending upon the parameters given. If H parameters are given, always use hybrid equivalent model. But if no parameters are given and you want to use DC analysis, you can use the T model as well as the hybrid pi model. So in the next video, I'll show you some problems based on this hybrid pi model, and you'll understand how to approach such kind of problems. Okay. So this will be all from this video. Thank you.
I hope all of you have enjoyed the lecture that we were providing, and all of you learned something very, very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very, very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank, because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of Plus subscription. So for 12 months the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for iconic for 12 months, it is 5250 with code Ankit ESE, it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution, and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that, my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JEE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JEE preparation can be done through these two channels, Unacademy SSC JEE and GS Terminal. And you can refer the other channels to the other friends in respective branches so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon so that you get notified whenever a new video comes. And share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.